Hey there, and welcome. You know, when you see those pictures of Earth from space, that beautiful blue marble, you just think, wow, so much water. It seems endless, right? But what if I told you that almost none of that blue is actually available for us to use? It's a pretty wild thought, so let's get right into it. Okay, look at this number, 0.006%. That's it. That is the tiny, almost unbelievable sliver of all the water on this entire planet that we can actually use. That one number just completely shatters the whole idea of a water-rich Earth, doesn't it? So how is that even possible? Well, let's break it down. And that question brings us perfectly to our first section. We're calling it a deceptively blue planet because that's exactly what it is. We're going to dive into why this world, which looks like it's practically drowning in water, is actually, believe it or not, facing a massive freshwater problem. Okay, so here's the deal. Yeah, about 71% of our planet's surface is covered in water. But here's the catch, the huge catch. The vast majority of that, we're talking over 97%, is saltwater in the oceans. You can't drink it, you can't water crops with it. Then, of the tiny bit of fresh water that's left, most of that is frozen solid, locked away in glaciers and ice caps. So the water we actually need to survive, it's just a tiny, tiny fraction of the whole picture. And of course, we all know water comes in three basic forms, right? Solid, as ice and snow, liquid, which is what we see in oceans and lakes, and gas, as water vapor up in the atmosphere. Now, keeping these three states in mind is super important because, as you're about to see, the fresh water we depend upon, well, most of it is actually hidden from us. So, where is this hidden water? That leads us right into our next section. We're literally going to look at the world beneath our feet, because that's where we find the single largest, most important reservoir of liquid freshwater that we have. So take a look at this. This is groundwater. And it's not what you might think. It's not some giant underground lake or river. It's actually water that has slowly seeped down from the surface and filled up all the little cracks and spaces between bits of soil and rock. This invisible resource is what feeds our wells and pumps. It's our hidden lifeline. Now, you've probably heard the term water table before, right? Well, it's actually a pretty simple concept. It's just the very top level of that underground water we were just looking at. You can think of it like the water line for the ground itself. And this is critical, because when that line drops, that's when wells start to run dry. So where is all this groundwater being held? It's stored in something called an aquifer. The easiest way to think of an aquifer is like a giant, natural, underground sponge made of rock and sand. It's soaked with groundwater. And some of these aquifers are absolutely enormous, holding incredible amounts of water that have been collecting for thousands of years. Okay, so if we're using this water, how does it get refilled? That's where a process called infiltration comes in. It's this slow, patient journey of rainwater and melted snow seeping down through the soil, trickling past plant roots, and eventually replenishing the aquifer. This natural recharge is absolutely vital. It's what keeps the whole system going. And that whole idea of recharge brings us to the really big picture, what we can call nature's recycling system. Because infiltration, that's just one piece of a truly incredible planet-sized engine that is constantly cleaning, moving, and reusing our water. And here it is, the star of the show, the water cycle. You probably remember this from school, but it's so fundamental. This constant movement of water from the Earth up to the atmosphere and back again is literally what makes life on this planet possible. It cleans our water, it creates our weather, and, most importantly for our chat today, it's what powers that whole infiltration process. Let's do a quick recap. It's basically three simple steps. First, you've got evaporation. The sun's energy turns liquid water into vapor, and it rises up. Step 2 is condensation. Way up high where it's cold, that vapor cools down and forms tiny water droplets, which we see as clouds. And finally, step 3, precipitation. Those little drops bump into each other, get bigger and heavier, and eventually fall back down as rain or snow or hail. And the whole thing starts all over again. So it sounds like a perfect system, right? A beautiful, self-sustaining loop. But there's a problem, a really big one. Our activities are putting this perfect system under a ton of stress. And that's leading us to a very scary situation, a situation we call when the well runs dry. And this quote really just says it all, doesn't it? It's a simple equation, really. We're pulling water out of the ground for our cities, our farms, our factories, and if we take it out faster than nature can put it back in through infiltration, that water table we talked about starts to drop. Simple as that. The result? Depletion.
So what's throwing everything off balance? Just picture a scale. On one side, we're piling on more and more weight. That's our demand, and it's soaring. Why? More people, more industries, and especially massive agricultural needs. Meanwhile, on the other side of the scale, the supply side, things are getting lighter. We're seeing less predictable rainfall, and things like deforestation mean that even when it does rain, less of that water can actually soak into the ground and recharge those aquifers.
Okay, so that sounds pretty serious, and it is. But, and this is a big but, it is not hopeless, not at all. And that brings us to our final section, smarter water, brighter future. The good news is we already have the know-how and the technology to manage this resource way, way better. And check out some of these solutions. They're actually really cool. We can give nature a helping hand through things like rainwater harvesting, which is designed to help recharge those aquifers. We can bring back some incredibly smart, ancient water systems like baries or stepwells. And maybe most importantly, we can just use less water to begin with, using amazing tech like drip irrigation that puts water right where the plants need it and nowhere else.
This is such a perfect, everyday example of how our choices make a huge difference. Think about a paved parking lot or a concrete patio. It's like a shield. When it rains, the water just hits it and runs off into a drain. It has no chance to soak into the ground. But a simple grass lawn, or a garden, that acts like a sponge, allowing all that precious rainwater to seep down and do its job, recharging the groundwater right under our feet. And so, we're going to leave you with this question. Because understanding all this stuff, this hidden world of groundwater, the water cycle, the pressures we're putting on it, it's not just a science lesson. It's about realizing that the choices we make every single day, from the kind of driveway we have to how long we water our gardens, have a real impact on this incredibly vital and totally invisible resource. So the question is, what can you do to help recharge the world right beneath your feet?